storm alert, while the world prepares for fireworks to ring in the new year. The Sun has decided to launch its own display. But this isn't just a light show. Right now, a massive billion-ton cloud of magnetized plasma is hurtling toward Earth at millions of miles per hour. Sunspot AR4317 has erupted, and the NOAA Space Weather Prediction Center has issued a G22-G3 geomagnetic storm watch. This is the strongest New Year SEV solar storm we've seen in over a decade. But what makes tonight extraordinary isn't just the size of the eruption, it's the timing. We are facing a double impact scenario. A high-speed stream from a coronal hole is merging with the CME, creating a combined force that could push aurora visibility much further south than usual. Tonight, we break down the science of this impact. Why our warning systems only give us 48 hours, and how you can capture this once-in-a-decade event on camera. The anatomy of the double-impact visual 3D model of the Sun, showing Sunspot AR4317. Transition to a SOHO, LASCO C3 feeds showing the CME halo, toast. It all started on December 28th. Sunspot AR4317. A massive dark region on the solar surface crackling with magnetic energy unleashed an M4.2 solar flare. Now, an M-class flare is moderate, but the coronal mass ejection, or CME, it produced is a heavyweight. We're talking about 1 billion tons of solar particles. But here's the kicker. While that CME was traveling, a coronal hole, a region where the Sun's magnetic field opens up, began spraying a high-speed solar wind stream directly into the same path. When the CME hits tonight, at approximately 8:43 p.m. UTC, it will be cannibalizing the space in front of it, compressed by that high-speed wind. This double impact significantly increases the chance of a G3 strong storm. Current solar stats at a 20-year high. Solar flux currently at 196 SFU, 196 SFU, confirming we are deep in solar maximum. Thermosphere power, we are seeing elevated cooling radiation at 22.05 1010 1022.05 1010 W, 3:32 5 o'clock. Section 2, the 48-hour warning limit. Visual animation showing the distance between Sun and Earth. Light traveling versus plasma traveling. Many people ask, if we have all these satellites, why do we only get 48 to 72 hours of warning? It comes down to the physics of speed. When a flare happens, the light reaches us in 8 minutes. That's our first flash. But the CM, either actual physical cloud of particles, is much slower. Even a fast CME travels at about 2,000 kilometers per second, 2,000 kilometers per second time. Distance to Earth velocity of CME time equals velocity of CME distance to Earth. Despite our advanced tech like the SOHO spacecraft and the Mars Reconnaissance Orbiter tracking the cloud's trajectory, we can't truly know the magnetic orientation of the storm until it hits the Deep Space Climate Observatory DSCOVR satellite, which is only about 1 million miles from Earth. That gives us a final definitive warning of only 15 to 30 minutes before impact. The Carrington Comparison Visual sepia-toned historical sketches of the 1859 Carrington event. Comparison charts of storm scales. Host, is this the big one? In 1859, the Carrington event, the most powerful solar storm on record, caused telegraph wires to burst into flames. Tonight's storm is a G3. The Carrington event would likely be classified as a super G5. While we aren't looking at a global blackout tonight, the G3 levels mean we could see it. Power companies will be monitoring geomagnetically induced currents. Satellite drag. The atmosphere expands when heated, which can actually slow down low Earth orbit satellites. GPS glitches. Your navigation might be off by several meters. The James Webb Space Telescope is currently tucked safely behind its sunshield. And international agencies are using the same data-sharing protocols they've developed for planetary defense. We are prepared, but the sun is definitely reminding us who's in charge. Solar cycle 25. Why now? Visual graph showing the solar cycle peaks from 1900 to present, highlighting the current spike. This isn't a fluke. We are currently in solar cycle 25, and it is vastly overperforming. Initial predictions suggested this would be a quiet cycle, but the sunspot counts are the highest we've seen in 2 decades. This double impact event is a symptom of a sun that is reaching its solar maximum earlier and more intensely than expected. For us on Earth, this means 2024 and 2025 will be the best years for aurora chasing in our lifetime. How to see and photograph the aurora visual. Stunning users submitted aurora photos. On-screen text with camera settings. Okay, let's talk about the view. Where can you see it? The aurora oval is expected to push deep into the mid-latitudes. Primary corridor, Seattle, Minneapolis, Chicago, to Boston. Possible sightings, northern New York, Iowa, and even Nebraska if the storm hits G3 peaks. If you capture any great shots, tag us in the comments below. Don't forget to like and subscribe for more space weather updates. Clear skies, everyone.